The gut-brain immune connection and its impact on emotional and physical energy. The human body is an interconnected network where no system operates in isolation. Among the most profound and underappreciated relationships in biology is the gut-brain immune connection, a triad that fundamentally determines energy levels, emotional stability, cognitive clarity, and long-term health. The gut is home to trillions of microorganisms, collectively referred to as the microbiome, which perform essential functions beyond digestion, including the production of neurotransmitters, modulation of immune responses, and signaling to the central nervous system. The brain, in turn, regulates gut function through the autonomic nervous system, influencing motility, enzyme secretion, and the production of gut hormones. The immune system, largely housed in the gut-associated lymphoid tissue, acts as a vigilant mediator, responding to pathogens while maintaining tolerance to beneficial microbes and nutrients. The interplay among these systems shapes how we feel, how much energy we have, and how the body responds to stress, inflammation, and aging. At the heart of this connection is the vagus nerve, the primary communication highway between the gut and the brain. This bidirectional pathway allows the gut to send real-time information about nutrient status, microbial composition, and immune activation to the central nervous system. Signals from the gut influence mood, cognitive function, and even decision-making, while the brain sends commands to regulate gut motility, secretion, and immune vigilance. Disruption in this pathway through chronic stress, poor diet, infections, or dysbiosis can lead to fatigue, brain fog, anxiety, depression, and impaired energy metabolism. The gut is not just a digestive organ, it is a sensor and regulator of systemic energy and emotional state. The microbiome produces a remarkable range of bioactive compounds that directly affect the brain and energy systems. Short-chain fatty acids, SCFAs, such as butyrate, acetate, and propionate, are products of microbial fermentation of dietary fiber. These molecules support the integrity of the intestinal barrier, regulate inflammation, and influence mitochondrial function, thereby affecting cellular energy production. SCFAs can also cross the blood-brain barrier and modulate neurotransmitter synthesis, impacting mood, motivation, and cognitive performance. Additionally, gut microbes produce precursors to serotonin, dopamine, and gamma-aminobutyric acid GABA, neurotransmitters that regulate emotional balance and alertness. Imbalances in microbial populations can therefore manifest as emotional instability, fatigue, and reduced cognitive capacity. Immune signaling is another critical component of the gut-brain immune triad. Approximately 70% of the immune system resides in the gut, strategically positioned to monitor microbial populations and dietary antigens. When the gut barrier is compromised, a condition often referred to as leaky gut, immune cells respond to microbial translocation and food particles, triggering systemic inflammation. Chronic low-grade inflammation not only drains energy but also affects brain function, mood, and hormonal regulation. Elevated inflammatory cytokines can reduce dopamine and serotonin availability, impair sleep, and alter hypothalamic pituitary axis function, producing a physiological state indistinguishable from fatigue or depression. This explains why individuals with gastrointestinal dysfunction often report both mental and physical exhaustion. The HPA axis itself is highly responsive to gut signaling. Stress increases the release of corticotropin-releasing hormone, which influences gut permeability, microbial composition, and immune responsiveness. Conversely, a dysbiotic gut can amplify HPA axis activity, creating a feedback loop where stress, inflammation, and energy depletion reinforce each other. This bidirectional communication underscores why gut health is essential not just for digestion but for mental resilience, energy regulation, and long-term physiological homeostasis. Without microbial balance, the body struggles to allocate energy efficiently, leaving individuals perpetually fatigued, despite adequate nutrition and rest. Diet is the primary modulator of the gut-brain immune axis. Fiber-rich plant foods feed beneficial microbes, supporting SCFA production and immune regulation. Polyphenols, antioxidants, and phytonutrients interact with microbial enzymes to produce bioactive compounds that reduce inflammation and enhance cellular energy metabolism. Conversely, diets high in refined sugars, ultra-processed foods, and unhealthy fats promote dysbiosis, increase intestinal permeability, and trigger systemic inflammation. These dietary patterns not only affect the gut microbiome but also downstream energy availability, neurotransmitter balance, and stress response. Eating is therefore a form of biological communication. What we consume sends powerful messages to our cells, microbes, and nervous system about energy allocation and resilience. Probiotics and prebiotics are tools to support this triad. Probiotics introduce beneficial bacterial strains that can enhance SCFA production, compete with pathogenic microbes, and influence neurotransmitter pathways. Prebiotics, which are dietary fibers that feed specific bacteria, selectively promote the growth of microbes that produce anti-inflammatory and energy-supporting metabolites. While supplementation alone cannot compensate for a poor diet, strategic use of probiotics and prebiotics can accelerate restoration of microbial balance, support immune function, and improve both mental and physical energy. Hydration and electrolyte balance also intersect with gut-brain immune function. Adequate fluid intake supports mucosal barrier integrity, lymphatic circulation, and nutrient transport. Electrolytes such as magnesium influence smooth muscle function in the gut, enzyme activity, and neuronal excitability. Dehydration or mineral imbalance can impair motility, nutrient absorption, and microbial homeostasis, indirectly reducing systemic energy and cognitive function. Maintaining proper hydration and electrolyte status ensures that the gut-brain immune network operates at maximal efficiency, supporting vitality across multiple dimensions. Sleep plays a vital role in gut-brain immune regulation. Circadian rhythms influence microbial composition, gut motility, and immune responsiveness. Conversely, dysbiosis and inflammation can disrupt sleep architecture, delaying deep restorative phases critical for cellular repair, hormone regulation, and energy restoration. Adequate sleep ensures the coordination of HPA axis activity, immune surveillance, and metabolic signaling, reinforcing the cyclical nature of energy maintenance. Energy is therefore not simply the result of caloric intake, emerges from the coordinated function of gut microbes, neural pathways, and immune surveillance over time. Physical activity interacts with the gut-brain immune axis as well. Exercise stimulates gut motility, increases microbial diversity, and enhances SCFA production. It also modulates inflammation and promotes mitochondrial biogenesis in peripheral tissues, increasing energy availability. However, overtraining or excessive stress can disrupt gut integrity and immune function, highlighting the need for balanced activity that respects biological thresholds. Movement is not merely mechanical. It is a form of systemic communication that supports the energy economy of the body through neuromicrobial and immune pathways. Mental and emotional practices amplify the effects of gut-brain immune alignment. Stress reduction techniques such as mindfulness, breathwork, meditation, and social connection downregulate HPA axis activity, reduce systemic inflammation, and improve microbial composition. Emotional well-being translates into physiological efficiency, neurotransmitter balance, mitochondrial function, and immune regulation all improve, producing higher levels of sustainable energy. The body is most efficient when the mind is calm and the gut ecosystem is stable, demonstrating the indivisible link between mental and physical vitality. Aging is also shaped by this triad. Microbial diversity declines with age, intestinal barrier integrity weakens, and immune senescence accelerates. These changes contribute to chronic inflammation, reduced energy, cognitive decline, and diminished resilience. Strategic dietary patterns, targeted supplementation, physical activity, circadian alignment, and stress management can slow these age-related changes, preserving energy and functional capacity. Healthy aging is thus deeply dependent on maintaining the gut-brain immune network over time, highlighting the role of everyday habits and long-term vitality. In conclusion, the gut-brain immune connection is a central determinant of both emotional and physical energy. It is not simply a digestive concern. It governs neurotransmitter balance, hormonal rhythms, immune vigilance, and cellular energy production. Fatigue, cognitive fog, mood instability, and chronic low-level inflammation are often manifestations of disruption in this network. Optimizing diet, hydration, circadian alignment, physical activity, stress management, and microbial support creates a harmonious system in which energy is efficiently produced, utilized, and restored. The triad of gut, brain, and immune function represents a fundamental framework for sustainable vitality, demonstrating that true energy emerges not from isolated factors but from the coordinated function of interconnected biological systems. Understanding and nurturing this network allows humans to achieve peak performance, emotional stability, and long-term resilience.